As of now, we should all know regular unsigned binary, and I'm going to give a couple examples here. This represents the number 7. This represents the number 15. So this is normal binary like we've learned all before. What's really important is that we know it's unsigned. So now we're learning how to put a sign to it, how to make negative numbers. So the way that we learned in class is a really good way to know about it, and that way it's algorithmic. You'll be able to know why it's the number that it is. But I do have a shortcut that I'll show you later. So right now I'll just reiterate what we went over in class. So right now our most significant number, or most significant digit, represents the number 8. And so we're going to make the most significant number a negative number, and then everything after it will just be a normal positive number. So 4, 2, 1. So now we know that to get negative 7, well, obviously negative 8 is bigger than negative 7, so you're going to put 1 there. And how do you make negative 8 into negative 7? Well, you add a positive 1. So this signed is equal to negative 7, well, not equal to, represents negative 7. So I do have a trick for this. If you know the number unsigned, let's say 7 again, so that was 0, 1, 1, 1. If you know the number unsigned and you want to make it signed, or alternatively the binary you're doing is already signed but you want to make the number negative, then you can do this simple thing. Every 0 will be turned into a 1, and every 1 will be turned into a 0, and then after that you add 1. And you see that is the exact same as right here when we did the math. So that's just a really quick way to do it if you don't want to do the math. So next is expansion. So let's say that we wanted to expand our highest or most significant digit from number 8 to the most significant digit representing the number 32. So that's going to be 2 digits over. So if it's unsigned, it's like you'd expect. You're going to put zeros in front. Simply because those zeros don't affect anything. Signed, on the other hand, is a little more tricky because you need to pay attention to what side of the circle it's on. If it's on this side of the circle, it doesn't matter. You can add zeros like it's unsigned. If it's on this side of the circle, you add 1s instead. So the way that we would do this with our negative 7 would be 1, 1. That's the 2 digits that I added. And then 1, 0, 0, 1, which is what we already had. So this works because if we think about it in the same way we did signed before, our most significant digit is going to be negative 32. And then we add 16, which leaves us negative 16. Then we add 8, which gives us negative 8. And then we add 1, which gives us negative 7. So it works both ways. You can do the math to get it either way. It's going to be the same. So when it's signed, the way that you know which side of the circle it's on is whether or not there's a 0 in front or a 1 in front. If there's a 0 in front, that means it's a positive number and you can just add zeros. If it's a 1 in front, that means it's a negative number and you need to add the 1s instead. It's fairly easy. Zeros with zeros, 1s with 1s. So now we're going to go on to truncation, which is definitely harder. Let's hope I don't mess this up. So let's say now we have our sign negative 7. with the most significant digit representing the number 32. So let's say we want to bring it back down to where our most significant digit is 8. So what we're going to have to do is, okay, sorry about that, cat problems. So the way that you truncate this 7 into the other 7 that the other -7 that we had, is we basically do two's complement again to make it unsigned, or at least this is the way I would do it. I'm not sure exactly what the professor was saying. I might need to rewatch that, but this is the way that I would truncate. So right now we know, not what I meant to do. We know that this is -7. So what you're going to do is do the two's complement trick that I showed you, which means that you're going to do 0, 0, 0, 1, 1, 0, and then add 1, 0, 0, 0, 1, 1, 1. So we know from our binary knowledge that this represents the number 7. And right now we're considering this unsigned. So we switch from signed to unsigned, and now we're going to move it to the circle over, as the professor put it, and we're going to truncate it. And so because it's just a bunch of zeros in front, it's very easy to truncate it, and we can just slice off those two, and then we have 0, 1, 1, 1, which right now we know that that does not equal -7. That represents the number 7. So what you do is you just change it back using the two's complement rule again. And so you say 1, 0, 0, 0, and then add a 1, so that would be 1, 0, 0, 1. And there you go, you converted it back. If you have any questions about this part, just ask me. Maybe look it up online, because honestly I'm not entirely sure that that's the way that the professor wants you to do it. Anyway, so the whole thing with signed and unsigned in C is, if you say that, as the slides put, in X is equal to -1, but then you changed it to unsigned, right? So right now, this number, I'm not sure exactly how many bits an int is, but let's say that it's, I don't know, let's just use the 4 that we were using. So we know that -1 is going to be, well, I'm just going to use two's complement because I'm lazy about thinking. So we know that this is the binary representation of -1. So we also know that this can become unsigned. Like whenever you say something is unsigned, it's not converting it to anything. It's just taking this binary and then converting it to base 10 and using that integer instead of the integer that you put in there as -1. So in this case, this will be representing the number 15. So now y, like on the slides, if it was unsigned, would essentially be assigned the same value as 15.